So the next method of factoring that we're going to talk about is something called U substitution. This is not that bad, but can seem tricky at first. So let's just take a look. Our first problem here, this x squared plus 5x minus 24 should be old school. We should be like, okay, well, this is x plus 8, x minus 3. If that does not seem fairly simple to you, you need to go back and work on factoring trinomials some more, okay? If that was easy enough, then let's move on. This problem right here has the same structure, okay? Now, what we are going to do is we're going to try to force this problem, the second problem, to look like the first problem. And what we're going to do is we're going to take these big exponents that we don't really like that much and try and turn them into smaller exponents. And we're going to do that using something called U substitution. I want a U and I want a U squared, okay? And when we're in exponent land, if we are squaring something, that means we are doubling the exponent. So U in this case is going to be x cubed. U squared is going to be x cubed squared. All right, so I'm just taking what I decided U was and I'm going to square it. But in exponent land, this is doubling. All right, we're going to do 3 times 2 there. So U squared, when I simplify it, is x to the 6th. Well, that's great because I have an x cubed in my problem and I have an x to the 6th in my problem. So what I'm going to do is I'm going to take these substitutions, I'm going to go back to my problem, and instead of x to the 6th, I'm going to call that U squared, because U squared and x to the 6th are the same thing. And then instead of x cubed, I'm going to call that U, because U and x cubed are the same thing. And then minus 24. Well, now this purple problem is the exact same thing that we started with over here. So when I go to factor this purple part, I can say U plus 8, U minus 3. All right, but my original problem had x's in it. It did not have u's in it. So once I have this nice and factored out, I'm going to go back and resubstitute in my x's. So u is the same as x cubed. So now I'm going to call this x cubed plus 8 and x cubed minus 3. And now I have factored out this problem right here into its final factored form. All right, kind of weird. Let's do it again. So now I am looking for, what can I call u? Is there a term that I have that's just plain and then that same term squared? All right, in this case, u is going to be x minus 8, and u squared is going to be x minus 8 squared. All right, so if I square this, I get u squared. So now I'm going to come back here and I'm going to make my substitution. Instead of x minus 8, I'm going to call that u. So u squared plus 5u minus 24. Well, this is the same trinomial we've been factoring this whole time. So I'm going to factor that into u plus 8, u minus 3. All right, but now u is this x minus 8. So when I go to substitute back in, I'm going to substitute x minus 8. So I get x minus 8 plus 8 and x minus 8 minus 3. Well, I can clean that up a little bit. So this ends up being just x, and then times x minus 8 minus 3 is x minus 11. So this is my final factored form. So I used U substitution and then I cleaned it up. Now, if you are seeing this pattern, we can see that this middle term typically is our U. And then we want to be able to double the exponent to get our U squared. So let's see if that works here. So I'm going to say that U in this problem is x to the k plus 2. So I'm going to say u equals x to the k plus 2. All right, and u squared is going to be x to the k plus 2 squared. Well, let's see if that works out. So I'm going to multiply this exponent by 2, and I get x to the 2k plus 4. Does that match my first term? Oh, it does. So I'm good. So I have a u and a u squared, and they match the terms that I'm given. So I'm going to make my substitution. I'm going to say that this is u squared plus 5u minus 24. And this is the same trinomial that we've been factoring. So now I'm going to factor it into u plus 8, u minus 3. And my u in this case is x to the k plus 2. So my final factored form is going to be x to the k plus 2 plus 8 and x to the k plus 2 minus 3. Gross? Sure, but totally factorable.